Okay, if you guys want, we can run through questions and you guys are here. Yeah. So if you want to continue working by yourself and then just look up to check your answer, that's fine too. But I'll just kind of start running through it. Okay, so water facts. Which aspect of water makes it an excellent solvent? So remember that water looks like that, right? And so our hydrogen side versus our oxygen side, we have a negative and a positive side. And that's really something that makes it a polar molecule. So polarity does help. So not heat capacity. That one helps it maintain a temperature. Its crystal form is less dense than its liquid form. That's cool too, but that just makes it float, and that's how life can exist still in the cold weather. Has a low freezing point. Okay, not it. It is polar. It has to do with its structure. All right, so polar just means positive, negative. All right, which characteristic of water best explains its ability to dissolve a great variety of materials? So just like that, we're going to look for something having to do with molecular arrangement, which is letter D. Okay, so it's kind of a repeat question. It was two different ways that it can be asked. So remember, polarity does have to do with the molecular arrangement, giving it a positive and a negative end. So polar things can dissolve polar things. All right, so comparing the properties and types of each solution. So this is based off of these notes if you have them, okay? And so I'm just going to kind of be pulling from that. So size of the particles. So for a solution, they're small. They're small enough to stay in solution, right? Do the particles eventually settle or sink to the bottom? No. Homogeneous or heterogeneous? This one is homogeneous or homogeneous. Shows Tyndall effect. So Tyndall effect, if you remember, that was the laser thing that I had shown. And it spreads the laser out. It's why you can't have high beams and fog. So for solutions, no, it does not. You didn't even see a laser beam technically going through it. An example, we could say salt water. Or any of the chemicals that we can even put AQ, because we know when we look at a balanced equation, AQ is talking about solutions, okay? All right, so colloids. Colloids, if you remember, were things that we associate with things like milk. So I'll just start from the bottom here. So it was something that we associate with like milk or foam. Fog is an example of that, okay? So where we have these particles that are within another substance or solvent. So size of particles, these would be medium to large, okay? Do the particles eventually settle? And the key thing about a colloid is that they don't. So no, large particles are not going to settle. They stay suspended in it, all right? It's like a permanent suspension, all right? Does it show the Tyndall effect? Yes, because we have those bigger particles, and since it stays suspended, it has stuff to bump into, all right? All right, so we don't call it homogeneous or heterogeneous. That's why it's colored out, because it appears homogeneous, but it's technically heterogeneous, all right? So we don't have to worry about that. All right, so for a suspension, those are going to be large particles. Do they eventually settle? Yes, and that's what makes these special, okay? This one is considered heterogeneous. And it does not show the Tyndall effect except when it's like you just stirred it, then it'll exhibit it, but it only exhibits it like partially and for a short amount of time. So we go ahead and say no. All right, it's not the way to determine if it's a colloid or not. So, or it doesn't pass that test. There you go. So this one would be our muddy water. Remember, we also talked about anything that has pulp and you have to shake in order for it to go back into its liquid form. All right. So what is the Tyndall effect, and what is the only type of mixture that exhibits it? Tyndall effect is when light spreads out. Okay. So it's the ability of causing light to spread out. All right, so I showed you guys with a laser beam, and a laser is a very focused light beam, and so the fact that it would spread means that it was hitting enough particles, okay? And so remember that the only type of mixture would be colloid, okay? In a sugar-water mixture, what is the solute and what is the solvent? So remember, we have our picture on our notes, that's right there on your table, where you have a beaker of solvent, you have some sort of a solute, and together it makes a solution, right? So solute goes into solvent to make solution. So what is the solute in a sugar-water mixture? Any ideas? The sugar. And the solvent is going to be the water. Okay? All right, so that leads us to this next portion about electrolytes. So I'm going to show a quick video clip, and then we'll come right back and we'll answer the questions, all right? Because it's not something that you guys took notes over and things like that. I'm kind of relying on teaching you the basic part of it, and you'll be fine with it, okay? So just hang tight for just a second. Let me pause this. Okay. So he kind of said a bunch of examples of each of those things, but the big idea for electrolytes, something that you can kind of rely on, are ionic stuff. And then you don't know all your acids and bases yet. I'm sorry, I'll just say acids and bases. And then when we're starting to decide if they're strong or weak, we get better at that when we get into acids and bases. But I'll make sure to put a little note on what you're thinking. But ionic, acids, and bases. Basically, covalent stuff, we're just saying it's not. All right, so what is an electrolyte? An electrolyte is going to be a substance that when dissolved, or I'm going to put aqueous, when aqueous, okay, because you know that means dissolved in water, conducts an electric current because it has ions. A substance that fully dissociates, so the word fully is a strong electrolyte. A substance that only partially dissociates is going to be a weak electrolyte. A non-electrolyte does not conduct electricity. And we tend to think of covalent molecules, okay? Such as just water, just DI water, which means distilled water, sorry, or deionized water. So in this little list, we're saying classify the following as strong electrolytes, weak electrolytes, or non-electrolytes. We need to be asking ourselves if it's an ionic substance, okay? So we're just going to go off of that. So distilled water, that means H2O only, not what's coming out of our tap water, because that has some ions in it, okay? But distilled water with nothing in it, that is going to be a non-electrolyte for sure. Tap water is H2O plus ions, okay? It has some of the minerals in it and things like that. So that one is going to be an electrolyte. And we'll go back and we can start saying weak and strong, but Gatorade has for sure the ions in it because that's something that our body actually needs and things like that. So this one is going to be for sure a strong electrolyte. Let's go ahead and put strong with tap, by the way. Just go ahead and put SE. All right, a sugar solution. So that means we have this molecule in water, right? There's no metals in it. There's nothing ionic, right? So we're going to go ahead and say a non-electrolyte. This one here was in the video, okay? This is acetic acid. All right, so just write it, just so you know it. That means it's a weak acid. Okay, the fact that it's a weak acid tells us it's going to be a weak electrolyte. All right. Okay, and then potassium hydroxide. So that right there, we have potassium. So that tells you ionic. This is actually a base as well. It's one of our strong bases. So this is a strong electrolyte. Oh, I forgot to put weak. Sorry, weak electrolyte. All right. Hydrochloric acid was also in the video, right? So as long as it's in aqueous solution, this is a strong electrolyte. NaCl solution, we're going to go ahead and say strong electrolyte. Soap should be none, all right? What I need you guys to be able to do on the test is know an electrolyte versus a non, all right? The strong and the weak, not very important to me, okay? So I'll make sure that the question doesn't ask that or I'll give those points back. But you should be able to tell me if something is ionic. Your acids look ionic, so I don't even think we have to write anything with that, all right? But acids do have an H with Cl, right? So something along those lines, all right? We'll learn about acids and bases in the next one. All right, so next question says rate of dissolving. List at least 3 ways to increase your rate of dissolution. So how can we get something to dissolve faster? So those notes were the ones that were, I believe, connected to something. I don't remember what. I think we wrote them down. We wrote them down on the front of your page. It was like a little half sheet. And so on that, we wrote down stuff from the video that day with how can we get something to dissolve faster. Okay, so when we did that, we ended up finding there it is. I had it in here. It was these. So we looked at this little video clip, and so it was mentioned what was going on. So dissolving rate, increasing that, we're going to heat up a solution, we're going to agitate it, meaning stirring or shaking, and we're going to increase the surface area. So heat up, agitate, which is stirring or shaking. This is increased temperature. Or we're going to increase surface area. Remember, increasing surface area means crushing. Okay? Because what we're trying to do is we're trying to make more of the collisions happen between the water molecules and the little salt itself. Okay? Okay. So let's go ahead and